I'm sorry, but my Spanish is not so good, so we'll have to do this part in English. But I very much appreciate the opportunity to speak with all of you today at the Embedded Software Conference. It's a very exciting space for Hewlett-Packard, and what I want to do is discuss for all of you a variety of topics affiliated with embedded software. And maybe we're going to have to hit it with the... There we go. So today I wanted to talk about why embedded software is so critical to the industry, where it is used. We talked a little bit about that a moment ago, but I will provide some more examples of how embedded software is used in the industry. What is embedded software? Kind of what are the major components and what makes up an embedded software system? How does embedded software relate to a device operation? How does it work? What do you need to do to become a embedded software development engineer? What are the areas you need to focus on? And then, what are the embedded software opportunities in HP Costa Rica, right? So I've got to do a little advertisement while I'm here as well, too. So go on to the next one. So first of all, why embedded software? Embedded software is all about innovation. Embedded software creates the differentiation between an HP product and someone else's product. Without embedded software, you basically have nothing. Our hardware engineers and our ASIC engineers require an embedded software engineer to be right by them so that they can diagnose problems on their devices. So, you know, we find that to be very interesting, that the people that are developing the silicon chip don't know how to use it without having an embedded software engineer next to them, okay? Driving that innovation, making it work, okay? So the embedded software engineer is at the heart of the system all the time. You're part of the bring up. You're part of what I consider to be the most exciting part of the development of a product when you're involved in the embedded software. So it's really an exciting place to be, lots of innovation, and very important to the company. So where does embedded software reside? Okay, so we all know it sits in a cell phone, an iPod, all these devices that we carry around with us. They sit in cameras, in automobiles. In some of the latest BMWs, they have 6 separate embedded software systems embedded within that, controlling the engine, controlling the environment in the car, controlling the navigation systems, controlling the heat and climate, right? Making sure that the fuel consumption is optimized. It changes the characteristics. I had a friend who had a pickup, and he wanted to pull a bigger trailer. He got a new computer chip and plugged it in his pickup, and he was able to pull a bigger load because he was able to change the embedded software that was inside of his vehicle, right? So these are changes that are occurring in automobiles. Then you have, of course, your laptops, your computers, the PDAs. You have refrigerators. There's a new refrigerator, okay, that you can buy for your kitchen that when you run out of milk, there's the scan thing that's on there. You run that by your refrigerator as you throw it in the trash, okay? And then it creates a shopping list. There's companies that are now working with these devices so that as soon as you scan it in, they create the list and they bring it to your home the next day, okay? So this is all really, you know, exciting real-time things that are occurring even with a kitchen appliance, right? We're finding the systems are inside of those. Of course, televisions and entertainment is a whole new space and opportunities for embedded systems. And then, you know, where I work, right? So to introduce kind of my organization that works here in Costa Rica, we develop the chips, the ASICs, the embedded software, and the control systems that basically are involved in the connectivity into the internet, okay? So what we're finding is more and more of all of these devices need to connect back into the World Wide Web and then utilize that information to provide a better experience for the customer, okay? So having one device in isolation is powerful, but having a device that connects to the rest of the world is even more powerful. And so we're creating those devices that are moving many billions of packets, you know, per second. that then connect all of these devices together and bring it to life, right? And so, now you can see how this is used. So I want to give another example of a project that we're currently working on in Hewlett-Packard with Shell Oil. Okay, this gives you an example of all the parts that are coming together. So HP created a small device they called, it's a microsensor. It's a very small thing about the size of a fingernail, okay? These little devices can feel even the smallest shake of the earth, okay? They can also sense heat and radiation and other things too. But for this application, it's measuring the seismic, the ability, any kind of movement on the earth. So what Shell Oil was interested in is something that they could roll out across the desert, many kilometers, right? And we created these little sensors. We created the ability to communicate on these on a wireless scale. So they communicate wireless, even though they're very small. They communicate wireless to a device that's in nearby, and then those devices create a mesh of devices that then communicate to a centralized system. Okay. And so the way this works is that in the middle of this system, they bang the ground. Okay. They bang the ground, and then that transmits into the earth, and then the reflections that come back to all of these sensors give an indication of the density below the Earth's surface. And that density is what will tell you whether or not there's oil in the ground, okay? So we're creating, through a system of embedded software, some of these things are measuring the shaking of the earth, some of them are communicating back to the home deal, some of them are then taking all the information from all of the devices and then pushing those back into the centralized system to tell where to drill for oil and how to find oil. They're also thinking of using these as border control, so you can feel footsteps, okay, and be able to tell if something's coming. We talked about earlier maybe having the ability to find out if there's someone that's maybe in a forest that they're not supposed to be there. These kinds of systems can be used for that. They're also used for forest fires. Okay, so this is an application of an embedded system that is networked, that is used in a real application today. So to go back to what is these embedded systems and how do they work? So they work very closely with the hardware systems. They're very aware of the components that are within the system itself. It's an extension of the hardware component. When we were first doing Ethernet routers, right, the things that run the internet, they used to run on basically what was a PC. The problem was they ran too slow. So to run it at the speeds we're talking about, we had to move a lot of those capabilities into the ASIC. So what was once in embedded software now runs on a chip. And today, what we find is that more and more applications that currently run in the embedded firmware run on the ASIC, and then more things are added on top in the embedded firmware space. So really, the embedded firmware is an extension of the hardware. It's limited by some of the hardware constraints, so those have to be moved into the ASICs. It enables us to create specialized ASICs in conjunction with the embedded firmware. We design these things for speed, and then we make sure they're connected to external systems. Really, it's the embedded systems it's this embedded software that brings the devices to life. Without that, you have nothing. So, how does this software work? Okay, so the first thing the embedded software does is it loads itself into memory, and it configures all the hardware that's on the device itself, right? So it creates, and then it has to do this in a secure fashion, because of course if you bring up a phone, a device like this, and it's not secure, then you have an issue. So there's also an element of security to embedded systems. It coordinates then via protocols to talk to other devices. Okay, that's kind of the next thing the embedded system does. After it brings up the system, it has to find out where it sits in the ecosystem. Then it has to optimize the system for the performance and what it's trying to do. Okay, so it's all about optimizing the performance of the overall device that it sits within, whether that's an automobile or